Hello everybody and welcome to part one of the cabinet project in my free online woodworking school. It is great to have you here. In this video, we're going to be focusing on cutting, orienting and edge jointing the side panels for the cabinet. Let's get going. Now in the previous series with the dovetail box, we started with pre-prepared material, which is what we're going to be doing today, but many of you are asking about going into depth with the actual preparation of the timber itself, because some of you do have access to machines. So I thought I'd very quickly go through how I went about machining this up, and then we'll get stuck in with the normal hand tool stuff. So you can see here that we've got two different length panels to start with, and this is what's listed on the cutting list. The reason for this is because this is going to make up one side of the cabinet. This is going to make up one side of the cabinet plus the shelf in the middle. It's just easier if you add the shelf onto one of them because it saves you having to join together three separate panels, and also that shelf isn't very long, so edge jointing it together can be a little bit fiddly. It's often easier if you have a wider surface. It does make it more difficult to edge joint, but you know, it's practice, isn't it? Now in the box project, we very briefly covered edge jointing when we were joining the panels of the lid together in order to make up the width of the box. And in this series, I wanted to show you a different technique when it comes to edge jointing, and can be easier, and many people questioned why I didn't include it in the initial series, and we'll get to that later. So when I went to the timber yard, I picked up a piece of American white ash that is through sawn. So we've got some quarter sawn faces, we've got some cathedral crown cut patterns, and then it's like a quarter sawn, rift sawn pattern here as well. Now this board is in fact wide enough to make up the depth of the cabinet, meaning I could have just shoved this through the thicknesser and planer and then there you go, it would have been done. But unfortunately for me, I wanted to demonstrate edge jointing of timber so that I could show you this new technique. What that did mean, however, was because I had to slice up this board anyway, it meant that I was able to choose exactly what parts of the board I wanted to make up the sides of the cabinet. And so this piece here is where those components came from. You can see that I've left the middle of the board out, but I've cut the components out the sides, and that is exactly where that quarter sawn and rift sawn pattern is. We've got nice straight grain in these areas that have been cut away, and I've just left this area with the kind of curvy, swishy grain. It's obviously not the most efficient use of material, but it has allowed me to get some lovely straight grained pieces of wood to make up the sides of the cabinet, which are going to be viewed the majority of the time when you look at the cabinet, whether you've opened it or whether it's closed and just sitting on the side. I think it's really going to pay off having these straight grained faces, and also it means that the edge joints within them are going to be less visible because they're going to kind of get lost in that linear grain, whereas if you had a crown cut cathedral pattern crossing over that join line, getting those patterns lined up is almost impossible, and then it's quite easy for you to see the join line. Not that you'll ever see the join line anyway, of course. And also, when cutting these components to length, I cut them 50 millimeters oversized. So when they're edge jointed, if there's any misalignment with the ends, it's going to be cut off anyway, so it's not too much of an issue. As for this one, where we've got the side panel and the shelf jointed together, I've left about 70 millimeters just to account for the cut line in the middle and if I want to cut any extra off the ends. In addition to that, the final thickness of these when the cabinet is assembled is going to be 15 millimeters. However, I've planed these down to 16 for now, so that after they're edge jointed, I've got about a millimeter to play with when it comes to planing and thicknessing it to size. So the very first thing we're going to look at with this is the grain orientation with the side panels, and ensure that it looks like it's all made of one piece, grains flowing in the same direction, and also we've got a color match. So we can do that by either rotating things 180 degrees or obviously flipping them over. So there's lots of combinations we can play with here. What you might see here is we've got a little white spot on this piece of timber, which is probably a stain from when it was drying or something like that, and I don't really like the look of it. It could also be caused by this small defect we've got here that I'm pretty sure is where a bug or a worm has eaten through the tree at some point, and then the tree has grown and healed itself, but it's left this kind of mark on it. I actually quite like the look of that on ash for some reason. I don't know why, but there you go. So with this, I'm certain that that is going to be the bottom of the cabinet, and I'm going to hide that within the drawer cavity, so this defect will never be seen. So let's assume this is the top, that's the bottom, and this face is the inside, this is the outside face. So that is going to be our starting point, and I'm going to reference everything off that and see if we can get the grain flowing in a nice way. So this has kind of got a small curve to it, so I'm going to look on these and see if we've got another one with a small curve. This one is actually curving slightly. That's quite nice. So it's very, very slight, but there is some small lines that are kind of tracking through like that, so I quite like the look of that. And this one, again, there's a slight curve to it. So let's see what we got on here. Yeah, not a lot to play with there. This is more off at a diagonal by the looks of it. So that's not gonna work. That doesn't look too bad. Yeah, that's pretty cool. I like the look of that. So what we're going to do on this is what my students have conned the idiot's triangle. I'm not sure if that's referring to them or the person that taught it to them, but I'll take it. The idiot's triangle is simply a triangle drawn across all 3 pieces of wood, so that when you take them apart and they all get confused, then it's very easy to reassemble the idiot's triangle, and there you go. So next we've got the larger panel that makes up one side of the cabinet and also the shelf. And you can see here we've got this big swishy bit that kind of encroached on this panel when I was cutting them out, which is unfortunate. So I'm pretty certain I'm going to make that the shelf. And let's have a look. It actually has a nicer colour match that side. So we'll certainly have this way up. The other thing I might be able to do with this is once joining them together and cut it to size, I'll probably be able to rip off that edge and get rid of it anyway. So we'll make sure to orient that on the outside. Now let's see, again, we've kind of got it curving out a little bit, so we'll see if we can get another piece to match. I also think the colour of this is a little bit darker as well, and in fact there's a white patch there as well, which I don't really like. So actually, this could be the outside face, and then when we separate the shelf, I can flip that over. So, right, outside face, it's gonna be fun. That's pretty cool. So this piece is definitely tracking it here, and then there's a slight curve on the grain, which is following that contour around here. So we'll go for that. Yeah, do you know what? That's not bad at all. Let's just mess around with a few more. No, not quite right. Light patch again, don't like that. So we'll make him the inside. Yeah, I think that's gonna be it there. So on here, because they're gonna be separated, we will do 2 idiot's triangles. And I am just gonna check the back side of that shelf component to make sure I'm happy with the match on that. And yeah, that'd be quite nice. So this will definitely be the upwards face on the shelf, but this will be the back of the cabinet, so we can mess around with that after they're separated. So now that we're happy with the orientation of the panels and we've got our idiot's triangles laid out, it's now time to edge joint them. So as promised, I thought I'd show you a new technique when it comes to edge jointing that is often easier. I say easier in quotation marks because I don't like to tell my students it from the get-go, because it's often an excuse for laziness, and also they don't necessarily think about what they're doing as much as they should do, and just kind of think that this technique will do all of the work for them, which it does do a lot of it, but it doesn't do everything. And it's really important you have a basic grasp of how to achieve a good edge joint, especially when it comes to preventing surfaces from being bowed or twisted, because that is something that this technique will not necessarily fix very easily. So I'm going to show it to you. Give it a go, but please don't see it as a way of just not thinking about what you're doing and hoping that it will do all the work for you, because it really doesn't. The method is quite simple. What you do is you get 2 of your components where you've got your idiot's triangle laid out, and you fold them apart like a book, and then get those top surfaces lined up. And I can see at this, looking at my idiot's triangle, that is definitely a join face, and then here, that's definitely a join face as well. We'll clamp those together in the vise, and what we're going to do with this is plane these 2 components together with the aim to get a nice square edge on the end grain of both of these pieces. Hopefully you can see that that is 2 pieces of dark paper there, and by planing them together we're going to get a nice 90-degree edge. The reason you stack them together is not to make the process quicker and get 2 edges done at once, which it does also do to some extent, but because if there is any error in your planing where you've got an angle on it or whatever, it will cancel itself out. If I flip these over, so again, looking at the end grain, let's say you plane them together, but it's at a small angle. What you can do is when you fold this back round, you can see that the error cancels itself out, which is why it's really important you fold them like a book, because if you don't do that, then it will not cancel itself out and your alignment will be wrong. So if when I was planing, I was a little bit biased to the right, your left, then flipping it round will cancel itself out. Works exactly the same if I was a little bit biased to my side. Then by planing it down like that, flipping it over, and then you've got a nice straight board where those errors have cancelled themselves out. But please just be aware that when you use that method, you still need to employ good planing techniques and aim to get it square. Because when it comes to joining these together, if these are really off and you've got some glue on that surface, they're going to start wanting to slip apart as well, unless you've got some method of location like a domino or a biscuit, for example. But the majority of us who don't have access to those machines will just need to rely on a simple butt joint, and joining stuff like that is a royal nightmare. So aim to get it as square as possible. This is a very good technique for cancelling out minute errors, but it will not do everything for you. In addition to this, it will not sort out bows in pieces of timber where you've got two curved edges joining together, and it will kind of fix twists and things if you've got a slight twist on the edge of that board, but it doesn't do it brilliantly. So when I showed students this in the past, I kind of pitched it as a good way of fixing all of your problems, but then when they started having problems associated with twisted and bowed timber, they came to me all confused saying, well, your foolproof method isn't working. So just keep that in mind when you use this technique. That is why I didn't show you it in the box project. I was showing you how to just plane single board square one at a time to ensure that you've got good planing technique and you don't rely on any special techniques to get the job done for you. So for this, I'm going to be using a low angle jack plane, but to be honest, any jack plane will do the job. In fact, you could probably do this with a smoothing plane, but because of the shorter base on the plane, it may be a little bit more difficult. So if you haven't already, have a look at the tool list for this project, which is viewable on my website. It includes a list of my recommendations for different jack planes to suit different budgets. So we're going to set this up so it's taking a very, very small shaving, nice and controlled. I have also sharpened a very small camber on this blade, which will make it easier for me to square this up throughout this edge jointing process. The camber is so shallow that it shouldn't affect this edge jointing technique that we've got going on. However, if you have a really cambered blade that takes a massive scoop out of that, then it is gonna cause some issues, but your plane shouldn't be that cambered anyway. If you're not sure how to camber a blade on a plane, have a look at the supporting resources for this lesson on my website. Just scroll down and you will see them there. So what I forgot to mention was that these two edges are straight off the bandsaw after I sized them. So what I'm doing at the moment is just focusing on removing those saw marks, taking nice even strokes to the plane down the center until I get a nice flat surface with no saw marks left. After that, that is where we'll start addressing the edge to see if it's out of square or not. With any luck, it will be straight off the plane, but it never really is. And what I am getting here is a lovely, lovely bit of tear out. So what that means is I am planing against the grain, meaning that I'm actually going to have to plane in the other direction. But in doing so, I would imagine that that's going to start causing tear out on here. We'll of course give it a go, but you can see this is again one of the limitations of this technique where you plane two boards together, because you might get reversing grain on one and you might be planing with the grain on the other. Just a very quick one explaining what it means to plane against the grain. You can see that this top edge is where we've got some horrible, hideous tear out. And I was planing in this direction on the board, and you can see that on the edge here, the grain is kind of coming up at an angle. If you imagine that like fur, and you've got the cat's head up here and you've got the tail here, you can stroke the fur in one direction, i.e. that way. If you stroke the fur in that direction, it starts kind of peeling up, and then in the case of wood, gives you a tear out. In the case of a cat, it claws your face. Whereas if we look at the other one, you can see that the grain's kind of going up at an angle here, which is good because it means that I'm planing with the fur. And then it's kind of dipping down a little bit here around this knot. And in fact, it does feel a little bit rough there where I'm potentially getting a bit of tear out, but it's not too bad. And then again, we're planing with the grain for a little bit, and then it's coming back up again here where we're going to be planing against the grain. It's a little bit rough there, but it's not too bad. So there you go, that's strike one for that method. As you can see, that planing them together like that is efficient, but the grain direction might not always work in your favor. So I'm actually going to have to plane these independently now, but it's a good thing I know how to do that after watching the dovetail box project. Here. So I'll flip the piece around now and we will give planing in the other direction a go, and that feels far nicer. I am getting a bit of a horrible squeak from the bottom of the plane, so just a little bit of candle wax on the bottom of the plane will really help. Make sure you hold on to the plane though, because it makes it super slippery when you do this. It does make the job a lot easier though. Right, let's see what we got. Yeah, so it's a little bit low on the right. Right, I'm happy that that is dead square now. The only thing I'm going to add to it now is that subtle spring joint that we covered in the box project. So we'll do that by taking a short stroke in the middle, lifting it up, slightly longer one, and then stopping just shy of the edges for our final pass. Check that it's still square. Lovely. So I'm now using techniques from my video how to plane correctly when doing this, and the particular technique involves using my index fingers as a fence for underneath the plane, making sure they're not anywhere near the blade, of course, and having my thumb planted on top. And it just gives you a nice reference when edge jointing long edges like this, rather than grabbing the handle on the top and potentially causing tippage. I guess because of the high center of gravity or something like that. It's just generally a bit easier if you have your hand looping underneath like that. Secondly, I'm locking my arms into my body and letting my legs carry the plane through. This prevents me from accidentally introducing any twist into the edge of the board from just using my arms, because you will naturally have some sort of twist once your elbows extend, whereas if you have everything locked in place, it's quite difficult to actually twist your arms. It also encourages you to take your time with it, because it's quite difficult to do that movement quickly, whereas that you can do very quick. So there you go, here's the boards jointed together, and you can see that the spring joint has produced the tiniest gap in the middle. And this is one of my favourite quotes from a luthier called Ben Crow. I watched a video a few years ago where he was talking about edge joints, and he said if you can't close the gap by just the pressure of your hands, then you haven't done your job correctly. And I really like that, because if your hands can do it, clamps can definitely do it. But at the same time, it means you're not asking too much of the clamps, and you're not asking them to force together something that shouldn't be shut. That's the kind of precision we're going for here. And I'm pretty happy with that grain match as well. I like that. So we're going to try that edge jointing technique again on this other surface. This one's going to take a while to clean up. We've got some proper, that's rough saw marks from the timber yard there. So yeah, we're going to be going at this for a while. Right, so get them together, fold them up, make sure they're nice and level. I've gone for a slightly deeper cut this time, but I'm prepared that I'm going to have to back this off at some point. Hey, looks like we're planing with the grain on both these pieces. That is good to know. So this is exactly what my students would do. They'd finish planing it, they'd get it flat, and then take it apart and hope that it goes together. But like, you haven't checked for bows or anything in the timber, which there is a slight one. Can feel it pivoting in the center. And, you know, while it's here, you might as well check if it's square or not, which this isn't. So we'll fix that now. We'll get it as close as we possibly can before we start losing our mind, and then we'll take it apart and test the fit. The other problem you may face when doing this technique is after you take it apart and test the fit, it's difficult to get it back in the vise and make it perfectly aligned, which means even if you had the tiniest adjustment to make to the squareness or whatever, that adjustment can be difficult to make if these are slightly misaligned. So again, it's another reason to really make sure that you've got it as close as you can off the square and off the plane before taking it apart, because it will be difficult to get back together in the vise in this exact same way. Right, we are getting little bits of tear out now, so I'm going to back off the plane because I've still got it on that rough setting. So it's back at 0 now. Bring it out until it starts taking a cut. There it is. That's looking nice. So we'll do a few more just to make sure that we're getting nice consistent shavings, because I can see that the shaving is getting full width along here, and then it's dipping off a bit in the center and then full width again. So I'm looking for that shaving to be nice and consistent over the whole thing. I think that's it there. So we'll check that it's square still. Dipping off a little bit. Right, that's good. So now we'll do the spring joint on this. And then hope that these goes together. Okay, they've gone together nicely, but that spring joint was not as good as it could have been. See, we've got a little bit of a rock on it. That is not good. So I've got a choice. I can either try and put these back together in the vise and get that spring joint planed in them simultaneously, or I just clamp them up in the vise one at a time and plane that spring joint independently. And I think that's the method I'm going to do. I don't want to risk any potential misalignment of these when I re-clamp them and thus throwing off the squareness and taking me back to square one. We will just do them one at a time and focus on that spring joint. Once again, quick check on the bench. So you can see there's a small gap in the center, but if we push that together, completely disappeared. Very nice. So that's the shorter panel done, and now it's time to move on to the larger pieces. These are exactly the same. You can employ all the same techniques, but seeing as it's a longer edge, it's going to be slightly more difficult, so you're going to just need to use a little bit more patience with it. If you do really struggle, then just separate it at the shelf and do them independently. But if you want a bit of a challenge and you want to save yourself a little bit of effort later, then do it all in one hit. Also, if you happen to own a jointer plane or a number 7 or whatever you want to call it, then that is the time to use this, because a jack plane might be a little bit too short for this edge, whereas if you've got a longer sole plane, then it's going to be a bit easier. In fact, I'm going to do that. Right, so got all the edges jointed, and I'm just going to double check them in the clamps now to ensure that the joint is good on both sides. I like using lightweight parallel jaw clamps to do this, just because they don't tend to distort the piece that much and they're very easy to adjust and everything. And I reckon I will get 3 on here, although the spring joint technically means I could just clamp it in the middle. I might as well put some extras on because I got them. Now when we clamp this up with glue, we're also going to put some cauls on it as well. That's CAULS, and these will prevent it from bowing under the pressure of the clamps and keep it nice and flat, because we don't really want a bowed or twisted panel when it comes to flattening it later, or we want to minimize that as much as possible. But that is looking proper nice. Look at this side. Yeah, that one is perfect. So then we'll try the longer one. This one is proving more difficult to check because one of these pieces is slightly bowed along its length, so it's not really referencing off the jointed face very well. So I'm just going to have to see what these clamps tell us. Okay, that side's looking good. Brilliant. Right, we're all good. So the edge jointing is now complete and they're ready to be, well, they're almost ready to be glued together after we make those cauls. I'll just say that that is not an easy process, especially working on such thin edges. So I'd strongly recommend you have a look at the edge jointing process in the box project, and also have a look at my video on how to edge joint and square timber, because those videos go into much more detail in that process and will help you to absolutely nail that joint between the two components. So here's some clamping cauls that I've made up. These are just out of some thick leftover plywood that I had laying around, but they can be made out of wood or anything like that. I would strongly advise you tape the surfaces that's going to be in contact with the board with parcel tape. That's usually quite a good one because it will prevent it from sticking to any glue squeeze out coming from the board. Unfortunately, it seems I've done quite a lot of packing recently, so I haven't got any parcel tape. So we'll see what the result of that is. I'm just going to make sure I clean off as much squeeze out as possible. The other thing I could do is put some paper between that and the board, and then after the glue's dried, I should be able to rip that off and the paper will stay stuck there as opposed to this. But I'm probably not going to mess around with it and will probably regret it later, and you guys can learn from my stupidity. So these will be clamped on the bottom and the top of this board, and you can see by clamping both of those together, that's going to ensure that any bow or any misalignment is going to be pushed out of it. On this longer one, I'm going to try and get a caul on either side and also one in the middle somewhere. That's to press out any of the small bumps that that bowed board is introducing into this surface. I don't really want to be planing that out afterwards, so we'll make sure to get extras on there. As for the shorter one, that should be absolutely fine with just a caul at either end, but we'll judge that after the dry fit. So let's start with this big boy. I'm happy that those are all clamped up and all the gaps are closed. Now I've got one plain surface on these. This would be easier if I had 4 sets of hands, but we'll make do. 4 sets of hands. That means 8 hands, doesn't it? In fact, one clamp in the middle because these bits of plywood are so rigid, should do the job for me. What's important when you do this is you make sure that these are pretty substantial. You don't want a spindly piece of wood trying to press out this bow, because it's just going to follow the contour of the board that it's placed on. Plywood is really good for this, not only because this particular piece is nice and thick, but because of the structure of the plywood, layers kind of laid on top of each other with the grain alternating. Means you get a really rigid piece of material, especially when used end on like this. If I used it flat, there might be potential for it to bow and follow the contour, but up on edge like that, very little chance of it bowing. But don't overthink that too much. Wood will do the job as well, providing it's thick enough. So you can see that's pressed the board nice and flat, but down here, that's where the bow of the board is starting to be introduced and is causing some misalignment. So a third caul on here is definitely going to be needed. It's a bit overkill, but this will make it so much easier after the glue is dried. And I would recommend doing this even if you're using locators such as a biscuit or a domino, because even with those preventing any slippage between the boards, it is still possible to introduce a bow across the width under pressure of the clamps. You can do things like alternating the clamps, so have 2 on the bottom, 2 on the top, but it still can potentially bow. Whereas having big rigid cauls like this, then that's going to keep the panel nice and flat and will ensure that our cabinet isn't banana shaped, which we don't want. And the advantage of doing a dry fit means that I can be absolutely certain I have all the equipment needed in order to complete the glue up at my disposal. It's within arm's reach. I'm not going to be running around the workshop while there's wet glue on the components, trying to look for a certain clamp or a certain caul or something like that. I'm just fully prepared for the process. In terms of glue for these edge joints, I much prefer using Titebond 2. Titebond 2 is a yellow glue and it has quite a strong initial tack, which means that when it's on edge joints, for example, you don't get as much slippage as you would with Titebond 1 and Titebond 3. Unfortunately, I rinsed through all of my stockpiles of Titebond 2 the other day and I've only got Titebond 3. The other disadvantage of this is that it dries a bit darker compared to Titebond 2, which tends to dry a more yellowy wood colour, especially useful for ash. But I'm going to go with Titebond 2. The joints should be tight enough to prevent any darkening of the glue line, but if you have a choice in the glue, I would strongly recommend Titebond 2. It's listed on the tool list for this project, so if you haven't already, go and have a look at that. There you go, guys, that is it for part 1. We've got both of the panels gluing up behind us and will be ready to be cut to size and jointed at a later date. But for now, thank you very much for watching. I hope you enjoyed the video. Don't forget to press the like button, and if you're watching this on my online school, don't forget to scroll down and you'll find all of the supporting resources for this project. You're now ready to move on to the next lesson, which you can do so by clicking the link below, and if you haven't already, please subscribe as well. It really helps me out, and we will see you in the next video.